Can you all see my screen?
Yes, we can see your screen.
Okay. So today I'll be talking about mobile application architecture. Yes, mobile application architecture. And we all have an idea what architecture is. Basically, what first thing that comes to mind is building plans or floor plans and stuff like that. And it's not so different from what we will be discussing today. So basically, we're looking at to build your application for a business or just for yourself, whichever is the case. So before we commence, we'll be looking at what is mobile app architecture. We'll be looking at the types. We'll also look at the design, then also some factors to consider when choosing the type of architecture you want to use for your development. So what is mobile app architecture? It is a body of rules, yes, and techniques and patterns on how to develop a mobile application. And it also acts as a roadmap to follow for best practices. And when this architecture can help you avoid future problems that may lead to recreating many features of the app again. So these are the things you want to avoid. So you want to lay out a roadmap or a pattern that you will follow so that in future, if you need to scale up or make changes, you won't have to start all over again, building the app from the scratch. You just modify the parts you want to modify. So this architecture will set like a guidance for you for another for future as a reference for the future development or scaling up of your application. Now imagine if you want to build a house now, say you have an idea or you have a land, yeah, and you want to build a house. So you call an engineer and ask the person to build you, say, bungalow. So the person says, okay, yes, I can make you a bungalow, no problem, easy peasy. And it goes ahead to build like a room and parlor bungalow or something, yeah. No plan, nothing. He didn't give you like the schematics of the whole thing. He just built it and yeah, gave it to you. So after a while, say you have a family, you have children, or you want to expand the house or maybe add a floor to it. Then you call another engineer and say, okay, I want to scale up this house. I want to make it bigger. I want to expand it. He or she is going to request for the plans of the house. Why? Because he needs to know what he can modify. Because you cannot put a story building on the foundation of a bungalow. The house will collapse at the end of the day. So basically, that is what the architecture helps you to do. So with the architecture, you can know instead of adding a floor, I can just make it add more rooms on the side to improve the app. So that's what the architecture will tell you. So once you have the architecture laid out at the start, any expansion or scaling up you want to do will be easier because you already know what type of application you have and how you can improve on it. But when you don't have that schematics or the roadmap down, you might end up having to build an entirely new app whenever you want to develop or whenever you want to scale up or improve your application. So we look at reasons why you should have an architecture before you start to avoid costly or to avoid cost in development. Because yes, you have to start all over again to build a new app whenever you want to improve what you have. So that will be more costly to your business. And it's also hard to maintain when you don't have an architecture because you don't know where you can make changes or where you can improve on. So you don't want to touch things that will just make the app break down. So yeah, that's the under essence of having the architecture down before you start. And it is harder to build upon or scale when you don't have an architecture. And also you are prone to have errors in your application. A clearly defined mobile app architecture helps to support flexibility and agile development methods. It makes testing more efficient and makes feature maintenance easy and less prone to bugs. It will also save you time and save you money in the short and long term. And a good architecture will not be platform specific, but rather apply to native and cross-platform choices, resulting in a unified approach to development. So what this means that when you have a good architecture, it won't just be just to one platform, like say OS. When you want to have an architecture that works for multiple platforms, either you are making a cross-platform app or you're making a native app, so the architecture will work across all these platforms that you want to build on. And also, a good mobile application architecture will enforce good software development principles in the appropriate stages of development to help accelerate development, providing a clear path for data flow that makes work easier and also supports clarity over how to scale or expand the app in the future. So it is like a roadmap. So if later in the future you need to expand your business or you want to scale up your business or scale down, you have a plan to follow. You have a roadmap, you have layouts that you can use. So this is the normal mobile development cycle. You want to test, you release, you monitor, you analyze, you develop again, you test, you release. So when you have an architecture, it makes this life cycle easier because you know, okay, what you have done already, you know what you can, how you can modify it, you know what you can add to it. The testing is easier because there's already a plan for it. And you can also release newer versions and get feedback, monitor it in the market, analyze it, then develop again or update your app as you go on. So let's look at the types of mobile app architecture. We have the layered, we have monolithic, we have microservices, which most of us are familiar with. We have event-driven and we have service-oriented architecture. So a quick look at layered architecture. It is a traditional architecture and is often used on premise and enterprise apps, which are frequently associated with legacy apps. Legacy apps are like apps that are not getting new updates. They are like out of date, outdated apps. So that's what we mean by legacy apps. So you can really find this layered architecture in most of outdated apps. So because newer apps they tend to use like microservices and more components to just make it more diverse and flexible. So in a layered architecture, we can have several layers or tiers, often three. Or sometimes you can have two layers, sometimes three layers. You can make it four, depending on the kind of application you are building. But oftentimes we have three layers of in the application. And the layers help to manage dependencies and perform logical functions. In a layered architecture, they are arranged horizontally, and the layer above either call into the layer directly below it, like that, or the layer above calls into the next layer, depending on how the application works. You can see the pictorial diagram here. We have a presentation layer, we have the business logic layer, we have the data access layer, and the presentation layer is calling into the business logic, and the business logic is calling into data access, and data access is calling into the data source, which is like a server, like a backend. So basically, these arrows are like steps, and these are like multiple floors in the application. So the presentation layer deals with your UI, your UX, and the business logic deals with the what is it called? The system, the business system. Getting responses, or maybe someone wants to buy something and the admin needs to approve all that. So that's the part that the business logic deals with. Then the data access deals with the stored data, maybe like local storage on the app. Then the data source is usually the server, your remote server and all that. For a monolithic architecture, this is a single application stack, and it contains all the functionality within that one application. And it is very tightly coupled, both interaction between the services and how they are developed and delivered. Opting or tailing a single aspect of monolithic application has implications for the entire application. That means when you want to update one part, you might have to build the whole application all over again, because they are all so neatly coupled that one part affects the other. So when you make changes to one part, you have to make changes to everything in the app. So a single change to the application code requires the whole application to be re-released. That's what I meant. So because of this update, new releases typically can occur once or twice per year. I may only include general maintenance instead of new features. So because of it's quite hard or more costly to keep updating the app, because you have to release a new version all the time, not even a version, like you have to release a new app all the time, every time you make changes. So most times they just make maintenance features and all that. Here we have an example of a monolithic architecture. Sorry, the picture is not very clear. As you can see here, it looks similar to the layout, but the difference is that there are no arrows in between. So they are all tightly coupled. So they just work together like that in one application stack. And here we have microservices, and I'm sure we are a bit familiar with how microservices work. Each service or each component acts independently and still connected to other services and components. So when there are probably issue with one component, it doesn't affect the function of other components. So that's one of the major advantages of microservices. So look at microservices, it's both an architecture and an approach to writing software. With microservices, apps are broken down into small components independent from each other. So this component or process is called a microservice, and they are distributed or loosely coupled. So that makes them very flexible, and it's easy to scale and improve on it, because when you make changes to one component, or you just release the new version of the app, you just update the version. You don't have to create a new or build a new app from scratch again. So that's one of the major advantages of microservice. The goal of using a microservice architecture is to deliver quality software faster. So multiple microservices can be developed concurrently. So you can divide the work. Maybe you have multiple engineers, you work on this part, you work on this part, and they are building everything at the same time. And at the end of the day, they just come together and merge it, and everything just works perfectly fine. So if one part is slowing down, it doesn't affect the other part, and the work can still continue, the app can still function. So, and then we look at event-driven architecture. With an event-driven architecture, the capture, communication, processing, and persistence of events are the core structure of the solution. Say an event is any significant occurrence or change in state for system, hardware, or software. The source of an event can be from internal or external inputs. So an example is when you make a purchase, let's say on an e-commerce app. Yeah, so when you create an order, the order is sent, and that new order that is created will trigger some interaction with other parts of the application that will run some functions or maybe some notifications and what's it called? Create your order. Yes. So when you so that's basically how it was. So an event has to happen, or a new input has to happen before this system will kick into action. So that's how an event-driven architecture works. So yeah, these are the various components. So each were from the user end, that's the client end, another is created, and it interacts with the other service, and then an event notification is created that a new order has been created. So that will now interact with the payment service and also the email service, probably notifying the user that, oh, you created this order, your order will be delivered at this time and all that. So that's how an event-driven architecture works. So probably most times it's used for like e-commerce sites like Jumia and Amazon. So this is kind of architecture that they use. But yes, we have service-oriented architecture. I hope you guys can still hear me. Hope I'm not moving too fast.
Yes, we can hear you, David.
Yes, we can hear you.
Okay, thank you. The service-oriented architecture is a well-established style of software design and is similar to microservices architecture. The service-oriented architecture structure apps into discrete, reusable services that communicate through an enterprise service bus. In this architecture, individual services each organized around a specific business process. So you can see in this diagram on the side, we have the service customer, and the service customer interacts with the service provider, and the service provider also interacts with the service customer. So the arrow is going both ways. But at the same time, the service customer is interacting with the service registry. So, and if you can see the interaction here, discovering the services. So the service customer interacts with the service registry to discover what services are available in that application. Yes, then the service registry will now give back the feedback. So when the customer tries to access the service, he or she will be interacting with the service provider. Yeah, the service provider, and the service provider will now confirm this service. Okay, I'm going to render the service to you, or give out, or whatever the person is asking for. Then also the service provider publish the service to the service registry to make the service available for the service customer so that they can find it. So that's how this works. So these are like independent reusable services. They are all independent, but they all interact with each other. We have the client and the service provider and the service registry with like a database, and they both interact with this. Then looking at the mobile architecture design, we have presentation layer, we have the business layer, and we have the data layer. So these are like the most common layers that you have in any architecture. Okay. Picture is taking a time to load. There should be a picture here. Are you guys seeing a black screen?
Yes.
Yeah, we can see a black screen.
That's weird. There's a picture here. Anyway, okay. All right. So this is the design, the mobile architecture design. You can see this is the user, and the user interacts with the presentation layer, the business layer, then there's the data layer too. And all of this is in a mobile device. And you can see also local data, which is like local storage on the system, on the mobile device. Then we have the common configuration, security, and communication settings on the device also. Then you can see at the bottom here, we have the remote infrastructure. That's like the database or your server. So this is like a complete architecture of a mobile application. So this is a good design. Now let's look at the presentation layer. It has two components basically. It has the user interface and the UI process. So when you are discussing this layer, the primary focus is the end user's mobile application presentation. So you want your app to be presentable to whoever is accessing it. So you want to focus on your themes, the fonts, the colors, and shading, and make your app user-friendly. That's the important thing to consider when you are building your presentation layer. Then your business layer is for the elements on the business front. So this layer looks at how the app represents the business to the end users. The layer includes business components, workflow, and entities. The business layer is broken down into two parts to reduce its complexity, and this includes the service layer and the domain model. So service layer are for common application function sets, while the domain model is for knowledge and expertise linked to specific problems. Then we have the data access layer. These are to meet application needs. Okay, they offer efficient and secure data transactions. So it combines different parts, including data utilities, data access components, and service agents. So this is like the brain of the application, basically. So this is where like everything happens. So from this end, you can communicate directly with the remote infrastructure, that's your database. So this is the part that communicates to database and all that. So all data access functions are encapsulated in this layer, which manages all the required connections. In addition, it handles all data sources and CRUD, that's the create, read, update, and delete operations. Okay. So you can, from this layer, you can access, say, APIs in the database, and you can create data in the remote infrastructure. You can read data from there, you can update data there, you can also delete data there. And all of that is possible from this access layer. So basically, you just access the data in the remote infrastructure. So there's a few factors that you want to consider when you are choosing your mobile app development architecture. You want to look at your device type. As for your users, you want to look at the platform they use. So if your business is focused on iOS, so you want to know if you want to focus on iOS, or you want to focus on Android users, or you want to make a cross-platform application so that can work across each of these operating systems. So that's the first thing you want to know. You also want to check screen size, screen resolution, CPU, and RAM. I know sometimes if you download some applications, if you go to maybe App Store, Play Store, you'll see like requirements, or maybe you try to download online, they'll give you like requirements that okay, this system app can only work if your RAM is like 4 gig or your RAM is 8 gig and above, that kind of thing. So these requirements are stated before the app is being built. You get to know so that, because if you go ahead and download the application when you're using a 4 gig and it's supposed to have 8 gig, you might end up crashing your system. So all these are set out before they start developing. So they try to consider users' device before they start building the app, so you can make it more compatible and start to work freely without any issues. Another thing they consider is development framework. So you want to choose the right framework for your application. If you want to use Flutter, you want to use what's it called, React, you want to use Angular, so depending on what you're building, so you want to choose the right framework for your application before you start. So you don't just start with React and say, oh, it doesn't really work for me. Then you go back to, let me try Angular, let me try this one. But you want to actually state out the one that's the best fit for what you're trying to build. Then we have bandwidth scenarios. So before you build your app, you want to do your research. You want to look at the target population. Where are they situated? Are they found more in the urban areas or in the rural areas? And what is their bandwidth like? Are they on 4G? Are they on 5G? Are they on 3G network? Because that will determine a lot of how users will use your app. Because if you have an app that's heavy on graphics, it will take a lot of data to load. So, and because of that, you might have glitches, or the app might not function properly if those people in that area have poor connection. So you want to make your app, you want to reduce the graphic in your application, so that even if they are in a poor network area, they can still use the app and still function properly. So that's another thing to consider before building your app. Then user interface. Your UI, your UX are very important, because you want to make your app user friendly. Because when people use the app and they like what they see, they tend to come back. Or if they use it and they have a poor experience, they will most likely delete the application or look for an alternative. So you want to make your app user friendly and catchy, so that it draws their attention and keeps them there on the application. And that thing is your navigation. So the type of navigation you use on your app also matters. So some people, the most common ones we see is the hamburger menu, where you see like 3 dash at the corner on one side. Then when you click on it, another bar or navigation bar comes up, and you can now select where you want to go to. Then the other type of navigation, there's the scrolling, there's gestures, where you can just swipe on the app to move between pages. There's also the bar rails, and also a search. So you can just search for whichever page you want to go. So you have to determine which one is a good fit for the application you are building. So before you start building your application. Then we have push notifications. So the frequency of your notification, push notification, can also impact device battery life, which can in turn impact user retention. So if your app is getting push notifications like all the time, you keep sending push notifications, it might impact the battery life, and the person might want to delete the app. So just to save battery, because and look for other alternative that will not drain the battery so much. And also push notifications are a way that you can interact with your customer or with your clients. So if you want to have push notifications, you might want to reduce the frequency at which you send it out, because the more you send push notifications, the less they are inclined to open the application. Because if it's too much, maybe you're sending a notification every 2 hours, trying to, maybe you posted a new blog and you're pushing notification that, okay, there's a new blog every 2 hours. The person will get tired. So you want to reduce the frequency to give it space, and also know the perfect what's it called? The perfect way that you want to do it, that will make the user not get tired of the application, and also make it interactive. And also it's a great marketing tool, because like I said, you can create interaction with your user through push notification from your own backend or from the admin end. you can send them a notification, and that will make them engage with your application. So all of this you want to consider before building your application. So with that, we have come to the end of the presentation. I hope I was clear enough and you guys got a few points. Thank you for listening. Any questions?
Thank you, David. My question, can you hear me?
Yeah, sure.
My question is, mobile app architecture, is it part of UI design or UI UX design or front-end developer work first? And second, okay,
continue.
And second, what are the right tools or resources to someone can look into if one is planning to develop an application and you want to, in order not to end up in a problem after building the app, because if you have structure the way you explain, so what are the tools the required tools one need to develop this? So those are my questions.
Okay, for the first question, the architecture is not under UI UX, or it's not under front end or back end. It's all of those front end, UI UX, and back end are all parts of the architecture. They're under the architecture. So you want to know how your UX will be, you want to know how your front end will be, you want to know how your back end will be. If you are going to be using cloud storage, you're going to use like on-site data storage, you're going to be using just local storage on devices. You want to map those out before you start. So the architecture encompasses both the front end, the back end, and the UI UX design. All of that has to be they have to be laid out before you commence your development. So that's the first thing. So it's not under one specific part of software development. It's a general thing for everybody. So everything has to be organized. Then for your second question, you need to pick. You say you're looking for tools that can help you with your architecture. They are not tools necessarily. Like I said, it's just like creating a plan. Okay, you want to create a plan, so you need to pick the type of architecture that you need, that you want to use, depending on what you are building. So if you want to use a microservice architecture, so you want to build an app that is very flexible so that you can scale up easily in future. So you just pick a microservice architecture, then you divide the functions of that app, okay, into components or into microservices. So it's there for you to now choose how you want to divide your components. So you want to say, okay, this is component handles all the forms on the app. This component handles user data. This component handles signing and login authentication. So that's for you to decide. So they're not like, it's not like there are no tools per se that for mobile app architecture to develop the architecture. You just pick the type that is the best fit for you, and you work your way around it. So you just lay out your plan for how you want to build your app, basically. I hope that answers your question.
Not really, but thanks. Thank you.
Hello, Hello, David. Good morning.
Yeah. Good morning.
Yeah, sorry, my network was messed up a bit. So I wanted to ask, I think Patrick asked that question. I wanted to ask the mobile architecture, like, is it the work of UI UX, front end or back end, or is it teamwork? I know somebody has that question, but my network was messed up a bit, so I didn't get the answer.
So like I said before, it's encompassing. Okay. The UI UX, it's like building a plan. Okay, when you want to build a house, you have to get your architecture first, right? You have to get your plan. So even in the plan for the house, you include not just the construction. Okay, you include both the plumbing. Okay, where you want the sink to be, where you want the toilet to be, all of that. You include both say, or what's it called? What else do you put? I don't know, but the architecture of the house is just takes into consideration everything like the carpentry, all of that. So you want to have a solid plan. So that's how this works too. So in your architecture, the UI UX is part of it. The front end and all that is part of it. The back end too is part of the architecture. So you want to lay out, okay, what type of UI UX, you want to make your user interface friendly. You want to write out your fonts, your themes, the colors you want to use. You want to map those out already. For your front end, if you're using a microservices architecture, you want to create components for all of this. You want to write, okay, this component for login, this component for functionality, this component for forms and all that. So you want to map all this out that, okay, I'm going to make components for this. Then for your backend too, you want to write a map for it or a roadmap for it that, okay, I'm going to use local storage for my application. So every data is stored in the local storage, or I want to use an on-site storage, or I want to use a cloud storage for your application. So you're basically just picking what you feel is best for that your application or your business. So once you've gotten all this laid out, that okay, this is what, then you can start building on it and start working on it to build your app. I don't know if that makes sense to you.
All right, thank you. So it means that there is always a document at the end of the day.
Yes, you have to document. So it's that documentation that will help you when you are trying to scale up or scale down in future. So whichever one maybe, so you want to expand. So that documentation, you just follow it. Okay, these are the fonts I started with. This is the color we started with. This is the themes we started with. So we can improve on it or we can continue using it. This is the backend we started with, that kind of thing. So whoever is coming in to make improvements, we already know what is laid down. We see it and can step it up like that. So that's basically the essence of having an architecture for your mobile application.
David,
right,
thank you for the response. The reason I asked the question is that there was a time like 3 months ago, I attended the kind of tech meetup online. So they were talking about Figma, and then it's basically about the how to they use it for like a kind of survey, building plan, and all those things that you said in your presentations are similar to my experience in that meetup. So using it like creating how they want the application to be, the button and all that, different part of all the things that they will use inside the application have to be built with Figma. Because I just searched it now, I realized that I have so, but I really don't know where this particular structure, where it's maybe it's UI UX design or front-end developer work, because on its own, it's work on its own, building or creating how you want your application to work is work on its own. And I think it's something that one need to learn or something. That's why I asked the question.
Good morning. David, can I come in?
Yes.
Yeah, sure. Come in.
Okay. So from my own understanding, I also also into UI UX design. So let me try to break it down the way I understand it. So basically, when you want to build an house, as an architecture, you build like a frame. What's the word? Like a sketch of how the house would be. Like, okay, this is where the toilet will be. This is where the living room, the dining table, all the likes. So you've built the plan. How the UI UX is now going to be like a bricklayer. Like, okay, so this is how this is where we want the what's it called, the wall to be like. Okay, this is like the foundation. From the foundation, you follow the map. Like, okay, this person talks about we'll be using a blue or a red color. Then he start applying that to the design. Then from there, after he's done building the old design, which is something like a map for a developer will now go ahead to, okay, this is what we are working on. Like, okay, this is the visual layout. Okay, they want the button here. They want the login here, wherever the old component is. That's more of the developer's work. So the developer is building on what the UI UX has designed, why the UI UX designer is designing or on what the architecture, like, okay, this is the layout plan. I don't know. Does that make sense?
Yeah.
Yes, I'm listening.
Okay, so in Figma, we use it to build the whole app, but the app is just like like a map. Like, okay, so this is what they want to do. It is the developer that will now start working on that map. For example, just imagine going to a place for the first time in your life, and you don't have Google Map. You start asking around, like, okay, please, I'm going to this street. Sometimes people might start misleading you, like, okay, go this side, go this side. But Google Map will take you directly to where you're going to. So that's like what UI UX is to a developer. A developer can develop without a UI UX designer, actually. They can develop the whole thing. But in that process, there are a lot of stress that will be applied, like, okay, which color will go well, which we as a UI UX designer has already applied to the whole, make it easy for them. But during their own design development, if they don't have a layout plan, something that they are following, they'll just start thinking, okay, which color should I do? Where should the navigation bar be? Where should the link be? Okay, we have what we call sitemap. Like, okay, if they click this link, where is it supposed to go to? All this stuff has already been easy by a designer, by a UI UX designer. The developer is now building on that. So I don't know if you get what I'm saying.
All right, I get you. I get you right. I just be a little bit confused because of the
architecture.
The program I attended about the Figma. So I now think maybe it's part of the architecture. So.
Oh,
okay. Let me ask.
Good morning. Hi, David. Hi, David. Good morning.
Good morning.
Hello, David. Yes, sorry. My name is Joseph. Please, I joined late, but I just want to do a quick catch up. So to ask a question. So with this argument ongoing, I just want to ask. So whose core function is to design the wireframe and prototype for an app or a web app? Is it the architect or
engineer?
What is it?
A software engineer.
A software engineer.
Wait, though. Sorry, that's like confusing there. I thought that is the work of UI UX.
Hold on. It's in his UI UX is just
UI UX design
architecture. Hello.
Okay, yeah, we are here.
Not like the typical architecture.
I think everything is under architecture.
Yeah, that's it.
It's wireframe, not like it's typical architecture as well. Okay.
Wireframe is
that not what UI UX guys have been trained for?
That's what I think too.
Let me explain. I've told that UI UX, both the process of creating the UI UX is under the architecture. You get the process of building the application is under the architecture. And let me give you a quick what's it called? I'm coming. Let me see. Let's look at this microservices component now, the diagram here. So you can see in this microservices part, hold on, it's still loading. There's a UI UX, there's a UI microservice. Okay, the architecture divides all of these parts or all of these jobs into different components. And so when you want to, okay, there's a component for UI UX, so you want to give it to a UI UX designer to create, okay, this part.
Can anybody hear me? Oh, it's my network.
I can hear you.
I can hear you.
Yeah, okay. I don't know. Personally, I feel like the wireframes and the old design is under UI UX, but the architecture is more like the overview of all the products. Like okay, so this is the house we are building. This is the house we are building. So it's not left for, okay, whether we want to use this cement, this kind of thing, but it's just like the normal way of how the house will be built. It's just like an overview. That's what I just feel, though. I don't know.
Yeah, I think.
Hello?
Oh, okay,
Hello.
welcome
Yeah,
back.
I went off there for a while.
Okay.
So I heard Victor saying something about overview, right?
Yes,
So
yes.
to kindly
So
round up.
basically, that's pretty much
Yeah,
it.
yeah, out of
Yeah,
time.
the